Welcome and greetings to the Sleep with Science channel. I'm delighted you've joined us. Perhaps your day has been exhausting, or perhaps you simply enjoy drifting off to sleep while contemplating stars, galaxies, and the serene enigmas of space. Whatever brings you here, this evening's exploration is meant for you. There's nothing required of you at this moment. Simply allow your body to relax, your thoughts to ease, and your mind to wander. Tonight, we'll be examining the universe in its entirety. Not merely a single star or galaxy, but the immense expanding cosmos. We'll drift peacefully from one discovery to another, exploring black holes, primordial light, dark matter, and far-flung galaxies. Certain things might catch you off guard. Others might linger with you like a peaceful notion on the verge of slumber. And should these tranquil discoveries assist your rest, please consider liking and subscribing. It allows others to discover this space as well. When you feel prepared, let's start. The cosmos could be more ancient than we've calculated. Current estimates generally suggest the universe is approximately 13.8 billion years in age. This figure derives from analyzing the cosmic microwave background and measuring the rate at which space expands. However, not every method produces identical results. Certain observations of primordial stars and galaxies indicate they could be more ancient than this estimate permits. Others challenge the presumed expansion velocity or propose that dark energy might be evolving through time. These contradictions remain unresolved, and the majority of astronomers continue accepting the 13.8 figure. Yet the uncertainties persist. Might the cosmos be more ancient? Have we overlooked something essential? Perhaps what we consider the origin was merely one segment of a longer, more mysterious tale. Thousands upon thousands of rogue planets drift across space without suns. Not every planet circles a star. Some exist completely unattached, floating independently through the galaxy, with no sun to provide warmth or illuminate their atmospheres. These wandering planets might have originated normally, then been expelled from their stellar systems through gravitational turmoil. Some might have developed independently like unsuccessful stars. They're obscure, frigid, and virtually undetectable unless they transit before background stars or emit faintly in infrared wavelengths. Scientists estimate billions might exist in the Milky Way, potentially exceeding the quantity of stars. Each represents a quiet world, adrift in darkness, rotating alone in the enormous expanses between. No dawns, no dusks, simply perpetual night interrupted only by faraway starlight. The cosmos might recycle itself through endless cycles. The conventional model of cosmology portrays a universe that originated with the Big Bang and will keep expanding potentially eternally. However, certain theories envision a different narrative, one where space undergoes cycles of expansion and contraction. In these frameworks, the universe doesn't conclude with a frigid ending or ultimate compression. Rather, it renews. Upon reaching a particular threshold, it might rebound, contracting inward, then expanding into a fresh expansion. Every cycle might erase the previous structures, yet retain faint traces of what existed earlier. These concepts are theoretical, yet fascinating. They indicate that the cosmos might possess no genuine beginning or conclusion, merely a pattern extended across unthinkable durations of time, one cosmos producing another repeatedly without end. The most ancient light observable originates from 380,000 years following the Big Bang. Prior to that instant, the cosmos was a luminous haze, so heated and compact that light couldn't journey far without scattering. However, as it enlarged and chilled, it arrived at a crucial point. Atoms assembled, the haze dissipated, and light was abruptly able to travel. That primordial light is the cosmic microwave background, and we can continue detecting it presently. It's the most ancient direct transmission in space, not from stars or galaxies, but from the universe itself when it was just starting to become clear. The photons we detect now have been journeying for over 13 billion years, extended by the expansion of space into lengthy, cool microwaves. This light is weak but omnipresent, a peaceful radiance that bears the recollection of the universe's initial transparency. Certain stars possess planets composed almost wholly of diamond. In particular solar systems, the chemistry differs greatly from our own. If a planet develops with greater carbon than oxygen and the pressures are sufficient, something extraordinary can occur: a diamond planet. Scientists have identified at least one such possibility: a compact world circling a pulsar, probably the remnant of a deceased star. According to its mass, density, and makeup, the complete planet might be a crystalline form of carbon, fundamentally an enormous diamond. It's excessively hot to glitter, and it wouldn't resemble a gem close up. However, deep under the surface, massive carbon lattice might extend for thousands of kilometers. These unusual worlds aren't typical, yet they remind us how varied the cosmos can be. A planet composed of stone, a planet composed of gas, and occasionally a planet composed of crystal. The cosmos might possess no boundary, merely infinite curvature. It's appealing to visualize the universe as something with a border, a limit we might arrive at if we journeyed sufficiently far. However, space doesn't appear to function that way. Based on general relativity, the configuration of space is established by its matter, and present evidence indicates that the universe is either boundless or so immense and curved that it circles back upon itself. If that's accurate, you could theoretically journey in a direct line eternally, and ultimately arrive at your starting point, not by encountering a barrier, but by circling around curved space. This resembles how journeying around Earth doesn't expose a boundary, just a sphere. The cosmos might operate similarly on a far greater magnitude, not boundless in space, yet boundless in voyage. The Sun previously had a companion, and it might still exist somewhere. Certain astronomers suspect that our Sun originated with a companion, a sibling star created from the identical cloud of gas and dust beyond 4 billion years previously. Numerous stars form in pairs, and there's no basis to assume our Sun was unique. If it existed, this missing sibling would have separated long previously, drawn apart by the gradual gravitational influence of the Milky Way. It might continue existing somewhere, circling the galaxy on a separate trajectory, undetectable to us currently. Some hypotheses even connect this companion, called nemesis, to puzzling extinction cycles on Earth, although there's no concrete proof for that. Nevertheless, the notion persists that our Sun, constant and solitary in our atmosphere, might previously have shared its origin with a silent companion, long disappeared into the stars. A droplet of neutron star would be heavier than Mount Everest. Neutron stars are the compressed cores of enormous stars, remarkably dense remnants remaining after supernova detonations. They're merely about 20 kilometers across, yet their mass exceeds the Sun's. The substance inside is so compactly arranged that a single teaspoon of it would be billions of tons. If you envisioned a single droplet of neutron star material, it would be more massive than any mountain on Earth. That variety of density contradicts our ordinary experience. Atoms are compressed together so firmly that electrons and protons combine into neutrons, creating a variety of superfluid neutron mixture. Neutron stars are extreme entities, compact, dark, massive, and rotating swiftly. However, in their peaceful mass, they preserve the recollection of stellar compression, an ultimate state where matter becomes essentially pure gravity. Light from a single galaxy can arrive at us from several directions. Occasionally, light doesn't journey in a direct line. In areas of space where gravity is particularly intense, near enormous clusters of galaxies. For instance, space-time itself bends. This bending redirects the trajectory of light, like glass refracting a ray. It's termed gravitational lensing. And one of its most peculiar effects is that we can occasionally observe multiple versions of the identical distant galaxy from various angles. These images can manifest as arcs, blurs, or even perfect rings. They're not copies in space, but copies in perception. Various paths that light has followed through distorted spacetime to arrive at our vision. In several uncommon cases, astronomers have witnessed the identical supernova detonate multiple times as its light reached through various gravitational paths. It's a peaceful reminder that in the cosmos, even light can become lost, follow a more extended path, and continue finding its destination. The initial stars might have blazed 1,000,000 times more luminous than the sun. The earliest stars were dissimilar to anything we observe presently. Created from the pure hydrogen and helium remaining after the Big Bang, these stars, designated population 3 stars, probably developed with no metals whatsoever, rendering them enormous, heated, and temporary. Certain ones might have been hundreds of times the sun's mass. They would have consumed through their fuel rapidly, radiating 1,000,000 times more brilliantly than our own star, then compressing in magnificent detonations after merely a few million years. None of these stars endure presently, yet their temporary existences transformed the cosmos. They generated the initial heavy elements, distributed galaxies with light, and established the foundation for everything that came after, including ourselves. Their light is vanished now, yet their traces remain in the chemistry of primordial gas clouds and in the peaceful structure of the early universe. Dark matter flows through your body as you rest. As you remain motionless, dark matter drifts quietly around you. It's not some unseen vapor. It's a variety of matter that doesn't react with light, doesn't reflect, release, or capture it. However, it possesses mass, and it reacts to gravity. Our galaxy is encircled by an enormous halo of dark matter. And as Earth travels through this halo, trillions of dark matter particles are believed to transit through every square centimeter of your body each second. They don't impact with your atoms. They don't create a mark, yet they're present, phantom-like, omnipresent, and crucial. Without dark matter, galaxies wouldn't maintain cohesion, cosmic structures wouldn't develop, and the universe would be considerably different. We continue uncertain what dark matter comprises. However, we understand this much. It's portion of your reality, transiting through you quietly and constantly, even while you rest. Certain galaxies shine without any stars within. In the peaceful expanses of the cosmos, astronomers have identified galaxies that emit light but scarcely possess any stars. These spectral systems are abundant with gas and dark matter, yet display minimal to no indication of star creation. Certain ones might have shed their stars in turbulent gravitational interactions. Some might never have generated many stars whatsoever. Several are virtually undetectable, except in particular wavelengths of light, weak smudges in comprehensive surveys of the atmosphere. These galaxies question what we believed we understood about how galaxies develop and change. If they're abundant in dark matter, why haven't they constructed stars? If they possessed stars previously, where have they gone? These faint, peaceful systems drift through space like abandoned fragments of cosmic past. Remind us that not every galaxy is abundant with brilliant light. Certain ones simply drift invisible and unexplained. The cosmos possesses a cold region that shouldn't be present. In the cosmic microwave background, the weak radiance remaining from the Big Bang, there's a section of atmosphere that's exceptionally cold. It's not merely somewhat cooler than its environment. It's substantially colder and considerably larger than scientists anticipated. This cold region extends hundreds of millions of light years, and its existence doesn't entirely correspond with the smooth randomness we'd anticipate from early universe physics. Certain ones believe it might be the impression of an enormous cosmic void. Some speculate if it might suggest something even more peculiar, like the impact of our universe with another in the earliest instance of inflation. No clarification thus far completely matches. The cold region continues as one of the most peacefully disturbing mysteries in cosmology. Not a dramatic anomaly, yet a murmur that something regarding our cosmos might not be what it appears. The moon is gradually departing us. Annually, the moon drifts a small amount farther from Earth, approximately 3.5 centimeters. That's essentially the velocity at which your fingernails develop. This gradual withdrawal has been occurring since the moon developed around 4.5 billion years previously. During that time, it was considerably nearer, and a day on Earth was merely several hours lengthy. The reason is tidal friction. As the moon influences Earth's oceans, and Earth rotates beneath them, a modest transfer of energy progressively propels the moon outward in its orbit. It's a peaceful, persistent process, undetectable on human time periods, yet unmistakable across eons. In the distant future, Earth and the moon might become tidally secured, constantly displaying the identical face to one another. Currently, it merely continues slipping farther gradually as we rotate beneath its distant luminous light. Binary stars can exchange their exterior layers like partners in motion. In certain binary star systems, the pair of stars circle so intimately that their exterior layers start to contact. As they develop, one star can expand and transfer matter onto the companion, generating a graceful spiraling transfer of material. Occasionally, the exchange is peaceful and continuous. Other instances, it initiates bursts of light, swift rotation, or even a total fusion. The physics is intricate, yet the visualization is strangely graceful. Two stars secured in orbit, rotating intimately enough to touch and combine. One star might conclude stripped to a luminous core, while the companion becomes expanded and enriched. Their destinies are connected together. Certain of the most exceptional objects in space, like particular supernova or compact neutron star pairs, originate as these peaceful touching binaries. A reminder that in space, even stars can exchange, transform, and occasionally embrace. The vacuum of space is not genuinely vacant. Even in the most profound, darkest expanses of space, distant from any star or galaxy, the cosmos is never genuinely vacant. Based on quantum physics, what we designate vacuum is an ocean of motion. Minuscule particle-antiparticle pairs appear into being and disappear almost instantly. These quantum variations occur constantly everywhere, generating a variety of restless foundation to reality itself. They can affect the movement of particles, modify the conduct of fields, and even add to the energy of vacant space. This is portion of what produces dark energy, the enigmatic force hastening the expansion of the cosmos. Therefore, when we visualize deep space as quiet and motionless, that visualization is only partially accurate. Under the peaceful lies a performance of probabilities, a concealed hum of generation and vanishing, constantly just under the surface of emptiness. Time might progress at various velocities in separate areas of the universe. We consider time as constant, a rhythmic pulse that progresses the identical for everyone everywhere. However, in actuality, time is profoundly connected to gravity, movement, and the configuration of space-time itself. In areas where gravity is intense, like near a black hole or a compact galaxy cluster, time decelerates relative to locations where gravity is less intense. This isn't merely hypothesis. It's been verified by experiments, satellites, and atomic clocks. However, certain cosmologists speculate whether time might also differ on even greater magnitudes. Might separate portions of the cosmos experience time at marginally various velocities due to how space enlarged in its early instance? The concept is theoretical, yet it reveals peculiar possibilities. In a universe regulated by relativity, even time might not be fixed. It might extend, decelerate, or curve, peacefully influenced by the space through which it progresses. The Milky Way possesses a concealed halo that's more extensive than the observable galaxy. When we examine images of the Milky Way, we observe a luminous spiral. Stars, dust, and gas organized in attractive arms. However, encircling this recognizable structure is something enormous and predominantly undetectable, the galactic halo. It's an immense sphere of diffuse gas and dark matter that reaches far past the observable boundary of the galaxy, arriving at distances numerous times greater than the extent of the disk itself. This halo possesses primordial star clusters, wandering stars, and enormous quantities of invisible mass. It's maintained together by gravity, influenced by the past of impacts and fusions, and performs a peaceful function in the galaxy's steadiness. Although we can't observe it immediately, we deduce its existence through the movement of stars and the curving of light. The Milky Way, it appears, is merely the luminous center of something considerably larger, a radiant heart enclosed in unseen arms. We've identified light from a galaxy merely 200 million years following the Big Bang. The cosmos is approximately 13.8 billion years ancient. However, light doesn't journey instantly. It travels through enlarging space, extended and delayed along the route. That's why we can observe galaxies, not as they exist, but as they existed long previously. Lately, astronomers utilizing the James Webb Space Telescope recognized light from a galaxy that existed merely 200 million years following the Big Bang, a moment of time on the cosmic magnitude. That light has been journeying toward us for beyond 13.5 billion years. The galaxy itself is compact, weak, and primitive. However, it contains hints to how the initial structures developed. Witnessing it is like examining through a narrow opening into a reality we were never intended to observe. The cosmos in its initial chapters, when darkness was just starting to yield to stars. The extensive structure of the cosmos resembles a neural system. When astronomers chart the locations of galaxies across enormous distances, an unexpected pattern appears. Galaxies aren't distributed randomly. Rather, they accumulate together along thread-like filaments with enormous vacant areas, cosmic voids between. This interconnected network extends across billions of light years and is occasionally designated the cosmic web. What's mysterious is that when you magnify out sufficiently distant, this structure appears remarkably like a neural system, the variety discovered in the human brain. Compact nodes of galaxies resemble neurons, and the filaments resemble axons linking them. Naturally, the similarity is purely structural. The cosmos isn't contemplating. However, it's nevertheless peacefully attractive to reflect. The most extensive structure we recognize, and the one within your own consciousness, influenced by completely separate physics, can conclude appearing so peculiarly alike. Stars can vocalize through the vacuum of space. There's no atmosphere in space, therefore we don't perceive sound the method we do on Earth. However, stars continue producing sound, profound, gradual vibrations. That journey through their interior gases, like seismic waves through a planet. These pressure waves cause the star pulse and vibrate, and scientists can identify them by witnessing minuscule changes in the star's luminosity or surface movement. The discipline that examines this is designated astroseismology, literally, the seismology of stars. Every star possesses its own interior frequencies, like a fingerprint established by its dimensions, structure, and age. By listening to these stellar vibrations, scientists can examine inside stars and discover what's occurring beneath the surface. It's a variety of cosmic echolocation, a method to perceive the melody of stars across light years, even if the composition is quiet to human perception. Certain stars are more ancient than the galaxies they inhabit in. Galaxies are not constructed all simultaneously. They develop across time, combining with smaller systems, and attracting in stars and gas from other areas. That indicates certain stars within a galaxy can be more ancient than the galaxy's present structure. They might have developed in earlier smaller galaxies that subsequently combined into a more extensive one. These primordial stars frequently exist in the peripheries or in globular clusters, firmly connected groups that circle distant from the galaxy's center. Certain of them are beyond 13 billion years ancient, virtually as ancient as the cosmos itself. They possess the chemical signature of a considerably younger universe when there were less heavy elements and only the most basic atoms. These stars are like remnants, peaceful survivors from prior to the galaxy completely assembled together. Their light is ancient. Their narratives originated prior to much of what we recognize had even developed. There exist galaxies devoid of dark matter, and we don't understand why. Dark matter is believed to be the unseen adhesive maintaining galaxies together. It clarifies why stars in the exterior areas of galaxies travel faster than anticipated, and why galaxies accumulate the method they do. However, in the recent few years, astronomers have discovered galaxies that appear to contradict this principle. Galaxies that conduct as if they possess no dark matter whatsoever. Their stars travel as though only the observable matter is existing. This revelation was unanticipated, and it doesn't match easily into present frameworks. Certain scientists believe the dark matter was removed during previous impacts. Some speculate if we continue don't completely comprehend what dark matter is. Regardless, these peculiar galaxies indicate that the cosmos continues possessing secrets, and that the things we assume are universal might not be so. Universal ultimately. The sun resonates like an enormous booming bell. Profound within the sun, sound waves ripple through the plasma, reflecting from one layer to another and establishing the complete star into subtle, perpetual vibration. These waves aren't like the sounds we perceive with our perception. They're pressure waves, low, gradual, and distant beneath human perception. However, with sensitive instruments, scientists can identify them and utilize them to examine the sun's interior structure. This discipline is designated helioseismology. By witnessing how the sun resonates, scientists can chart what's occurring profound beneath the surface, its density, rotation, and even its concealed flows of heated gas. The sun in this manner functions like a musical instrument, enormous, intricate, and constantly performing. We merely require the appropriate instruments to listen, and what we perceive assists us comprehend not only the sun itself, yet stars throughout. Galaxies pursue filaments composed of something we cannot observe. The universe's most extensive structures aren't composed of stars or gas. They're influenced by something unseen, dark matter. Across billions of years, this dark matter created enormous filaments extending across space. And galaxies incline to develop and travel along these filaments like beads on a thread. We can't observe the filaments immediately, yet we can deduce them by witnessing how galaxies accumulate and how light curves as it transits through these areas. The filaments can extend hundreds of millions of light years and link enormous clusters of galaxies. Between exist great voids, virtually vacant areas where extremely minimal matter exists. The dark matter filaments function like a concealed framework for the observable cosmos, influencing how galaxies develop and where they proceed. And nevertheless, we continue uncertain what dark matter comprises. The structure is present, immense, invisible, and peacefully maintaining the cosmos together. Space can extend faster than the velocity of light. In normal situations, nothing can travel faster than light. However, space itself isn't restricted by that principle. Throughout the initial instance following the Big Bang, space enlarged so swiftly that areas of the cosmos were separated faster than light could journey between them. This wasn't movement through space. It was the enlargement of space itself. Even presently, distant galaxies aren't speeding away because they're traveling rapidly through space. They're withdrawing because the space between us and them is extending. And if they're distant enough, that extending causes them withdraw faster than light, which is why we'll never observe them again. It's not a breach of physics, yet a peaceful result of how space conducts on cosmic magnitudes. The cosmos doesn't require to hurry. It simply enlarges peacefully and persistently past what we can pursue. Our solar system travels through space like a helical spiral. It's simple to visualize the planets circling the sun in orderly flat circles. However, magnify out farther, and something more peculiar appears. The sun itself is traveling, circling the center of the Milky Way at virtually 1,000,000 kilometers per hour. As it travels, the planets pursue and trail, not merely circling the sun, yet spiraling through space following it. The combined movement generates a helical configuration, like a corkscrew or a twisting ribbon. Everything is in movement. The planets, the sun, the stars, the galaxy itself. There is no motionlessness in space, only graceful, perpetual drift. Even as we rest, we're tracing gradual spirals through a galaxy in movement, enclosed in layers of orbits within orbits. A performance so enormous, we never sense it. Even emptiness possesses a temperature. If you journey distant enough from stars, planets, and galaxies into profound intergalactic space, you'll discover yourself encircled by what appears like pure vacancy. However, even the vacuum possesses a temperature. That temperature is approximately 2.7 Kelvin, merely several degrees past absolute zero. It originates from the cosmic microwave background, the remaining radiance from the Big Bang currently extended and chilled by billions of years of cosmic enlargement. This weak radiation occupies the complete cosmos. Regardless where you proceed, it's present. It's the peaceful thermal signature of the early cosmos, nevertheless persisting, nevertheless quantifiable. And in the future, it will chill even more. In several trillion years, the cosmos might approach absolute zero, yet never entirely arrive at it. Because even in the most extensive vacancy, the echo of warmth remains. Quantum variations might have influenced the complete cosmos. At the tiniest magnitudes of reality, distance smaller than atoms, the cosmos conducts unpredictably. Minuscule random variations in energy can manifest and disappear in an instant due to the uncertainty constructed into quantum physics. And based on numerous cosmologists, those temporary random blips might have been magnified throughout the universe's initial instance, through a process designated inflation. As space enlarged at unthinkable velocity, minuscule variations were extended to cosmic dimensions. Those variations became the origins of structure, the locations where matter would accumulate, where galaxies would develop, where stars would ultimately ignite. In alternative words, the grand structure of the universe, the galaxies, the filaments, the voids, might all trace to fleeting random occurrences at the tiniest possible magnitude. Everything we observe presently, created from the trembling of emptiness. Dying stars can pulse like heartbeats across millions of years. Not every star concludes with an explosion. Certain ones diminish more gradually. And throughout their ultimate stages, they can pulsate, expanding and contracting in rhythmic cycles. These stars, designated variable stars, modify in luminosity across time. In certain cases, the modifications are constant and regular, repeating like a gradual heartbeat. The pulses are produced by modifications in the star's exterior layers, gases enlarging and cooling, then compressing and warming up again. Certain stars pulse every several days. Some require months or even years to finish a cycle. These rhythmic stars have been utilized to quantify distances in space since their pulsation. Configurations relate to their genuine luminosity. They also function as peaceful reminders that even in death, stars can maintain time, not with a clock, yet with a lengthy, gradual breath. Across cosmic ages, Earth exists within an enormous bubble of heated gas. If you might observe distant into the unseen wavelengths of light, past what your vision can identify, you'd discover that our solar system resides within an enormous luminous bubble of heated gas. It's designated the local bubble, and it extends for hundreds of light years in every direction. This bubble is believed to have been carved out by primordial supernova, detonating stars that expelled shock waves into the encircling gas, warming and clearing it out. Currently, our solar system drifts peacefully through this low-density area, encircled by a shell of hotter gas and dust. It's not hazardous. It's not something we can sense, yet it's present. A variety of peaceful chamber around us, created from violence long previously, currently portion of the gentle foundation of our galactic vicinity. There's an enormous vacant area following the Great Attractor. The Great Attractor is an enigmatic gravitational anomaly, an area of space so enormous that complete galaxy clusters, including our own Milky Way, are gradually drifting toward it. However, following this immense concentration of matter exists something even more peculiar. An area designated as the dipole repeller, where space manifests exceptionally vacant. It's not merely a section with less galaxies. It's an enormous cosmic void extending for hundreds of millions of light years. And strangely enough, its vacancy appears to propel galaxies away. Together, the Great Attractor and the dipole repeller generate a peaceful gravitational tug-of-war that assists influence the movement of our local cosmos. We're attracted forward by invisible mass and propelled backward by the vacancy past. It's a reminder that in the universe, both existence and absence can influence the trajectory we pursue. Neutrinos transit quietly through the Earth and through you. Currently, trillions of particles designated neutrinos are transiting through your body, and you'll never sense them. Neutrinos are remarkably lightweight, neutral particles generated in enormous quantities by the Sun, detonating stars, and even the early cosmos itself. They scarcely react with normal matter. They can travel directly through a planet or your complete body without creating a trace. Certain ones transit through detectors concealed profound underground, where uncommon impacts assist us examine them. However, most simply transit through undetected. These particles are throughout constantly, quietly streaming through space and matter alike. They travel at virtually the velocity of light, and nevertheless they almost never contact anything. The cosmos is abundant with movement, even when everything seems motionless. The most enormous stars can compress immediately into black holes without an explosion. We frequently envision the death of an enormous star as a turbulent supernova, a magnificent detonation illuminating the galaxy. However, for the most enormous stars, the conclusion can be peculiarly peaceful. Certain stars are so massive that when they exhaust fuel, their cores compress inward and gravity triumphs so thoroughly, so abruptly that even the exterior layers descend directly in. No detonation, no luminous farewell, merely abrupt disappearance. This process is designated a direct compression. In the instant, a star is vanished, substituted by a black hole, quiet, unseen, and crushingly compact. Astronomers have even witnessed stars that appear to disappear without a mark, as if the light simply extinguished. It's a reminder that not every cosmic conclusions are fireworks. Certain ones are murmurs into the dark. Galaxies can circle one another like moons around planets. We incline to consider galaxies as separated islands in space, yet numerous exist in compact groups where they react and even circle one another. Our own Milky Way, for instance, possesses dozens of smaller satellite galaxies. The large and small Magellanic Clouds are the most recognized. These companions travel around the Milky Way like moons around a planet, gradually tracing lengthy elliptical trajectories through space. Occasionally, larger galaxies extract stars from their companions, creating streams and tidal tails that extend across millions of light years. Across time, a smaller galaxy might be consumed thoroughly. These cosmic performances occur across billions of years, gradual, graceful reactions on a magnitude we can scarcely envision. In the peaceful of profound space, even galaxies can maintain each other accompaniment. The universe's most luminous detonations originate from compressing magnetic stars. There's an uncommon variety of detonation, designated a magnetar hypernova, and it might be one of the most luminous things the cosmos can generate. A magnetar is a neutron star with an unthinkably intense magnetic field, trillions of times more intense than Earth's. If an enormous star compresses into a magnetar and releases its energy rapidly, it can generate a burst of light and energy, distant more powerful than a typical supernova. These occurrences might be accountable for certain long-duration gamma-ray bursts, flashes of elevated energy light that journey across the cosmos and temporarily outshine complete galaxies. The detonation endures only seconds, yet its light can arrive at us from billions of light-years distance. It's one of the universe's most intense phenomena, generated by a compact object enclosed in magnetic fire, compressing in on itself. The boundary of the observable cosmos is not the boundary of the cosmos. When we examine out into space, there's a restriction to how distant we can observe. Approximately 46 billion light-years in any direction. That's the boundary of the observable cosmos. It's not a barrier or a limit. Merely the most distant distance light has possessed time to arrive at us since the Big Bang, considering the enlargement of space. Past that, the cosmos probably continues. We merely can't observe it nevertheless. And because the enlargement of space is hastening, certain portions of the cosmos are traveling away from us faster than light. That indicates their light will never arrive at us, not even in boundless time. The observable cosmos is like a bubble of perception, not the complete dimensions of reality, yet merely the portion accessible to us. Past that, additional galaxies, additional stars, perhaps eternally. Certain galaxies project jets of plasma for millions of light years. At the core of numerous galaxies exists a super-enormous black hole, and occasionally, as matter descends toward it, not every of that matter vanishes. Certain of it becomes captured in magnetic fields and expelled outward in narrow, powerful jets. Streams of plasma traveling near the velocity of light. These jets can extend distant past the host galaxy itself, arriving at lengths of millions of light years. We observe them radiating in radio wavelengths, creating enormous lobes that indicate their extent. Galaxies like these are designated radio galaxies, and their jets are among the most extensive structures in the cosmos. It's a peculiar contradiction. The most powerful outflows can originate from the areas around black holes where light can scarcely escape. Even quietness, it appears, can create an impression. There's a star that circles the Milky Way backward. Most stars in the Milky Way circle in the identical general direction, pursuing the galaxy's rotation. However, not every of them. There's at minimum one recognized star designated, HEO 4375439, that travels in the reverse direction. Its orbit is retrograde, cutting against the progression like a salmon swimming upstream. How did it achieve that method? One possibility is that it was portion of the smaller galaxy that combined with the Milky Way long previously, and its orbit reflects that older separate system, or it might have been propelled into its present trajectory by a gravitational slingshot, perhaps involving a black hole or compact star cluster. Regardless, it's a peaceful reminder that not every stars pursue the principles. And even in the enormous clockwork of the galaxy, there exist wanderers proceeding their own method. The center of the galaxy smells like raspberries and rum. It sounds like a joke, yet it's genuine. Astronomers examining the chemical makeup of a dust cloud near the center of the Milky Way identified a molecule designated ethyl formate. On Earth, it's connected with the flavor of raspberries and the scent of rum. Naturally, the galactic center doesn't genuinely smell. The vacuum of space wouldn't transport scent the method atmosphere does. Yet the existence of these molecules suggests that the intricate organic chemistry developing in profound space. There exist alcohols, sugars, and even amino acid precursors in interstellar clouds. It's not life, yet it's the variety of chemistry life might require. Therefore, while space might not smell like fruit and liquor, it possesses the building blocks drifting quietly between the stars. One galaxy is directly for the Milky Way, and it's presently contacting. The Andromeda Galaxy is our closest large galactic companion, and it's on a gradual motion impact course with the Milky Way. Currently, it's approximately 2.5 million light-years distance. However, that distance is diminishing. In approximately 4 billion years, the pair galaxies will start to combine. And interestingly, the exterior halos of both galaxies, their enormous clouds of heated gas and dark matter, are presently overlapping. Therefore, in a manner, they've started contacting presently. The ultimate combination will be more of a graceful blending than a collision. Stars will predominantly transit by one another without impacting. Across time, the pair spirals will transform into one larger elliptical galaxy. We occasionally designate this future system Milkomeda. It's a lengthy wait, yet it's presently in movement. A cosmic meeting unfolding across billions of years. The cosmic microwave background continues radiates all around you. Every portion of the cosmos, including the space around you currently, is occupied with a weak radiance designated the cosmic microwave background. It's the afterglow of the Big Bang, light released when the cosmos was approximately 380,000 years ancient. During that time, the universe was a heated, compact plasma. When it chilled enough for atoms to develop, light was ultimately able to journey. That light has been traveling ever since, extended into microwaves by the enlargement of space. Presently, we identify it as a near uniform radiance in every directions. It's not something you can observe or sense, yet sensitive instruments can detect it as a variety of cosmic murmur. This radiance is the most ancient light we can witness, a peaceful transmission from the universe's childhood, nevertheless echoing through space and time. Certain supernovae are powered by unseen compression, not light. Supernovae are recognized for their luminosity, enormous detonations that temporarily outshine complete galaxies. However, not every supernova are luminous. Certain ones are what astronomers designate failed supernova. In these situations, an enormous star's core compresses, creating a black hole. However, the exterior layers don't detonate outward in an observable flash. Rather, they might descend inward, supplying the black hole quietly. In uncommon instances, we've observed stars that appeared stable abruptly disappear from perception. No detonation, no diminishing radiance, merely darkness. These disappearances indicate a compression so thorough that virtually every of the energy is consumed. There's nevertheless tremendous violence, yet most of it is concealed. It's a reminder that not every cosmic deaths produce noise. Certain ones occur in quietness. Profound within gravity's grasp, there exist complete galaxies composed predominantly of gas and dark matter. We frequently visualize galaxies as luminous spirals or radiating ellipticals abundant with billions of stars. However, certain galaxies are scarcely observable whatsoever. These faint systems possess extremely few stars, yet they continue to possess mass, predominantly in the variety of gas and dark matter. They're challenging to identify with regular telescopes and frequently manifest only as weak smudges or through indirect measurements. Certain of these galaxies might be unsuccessful systems, structures that never created numerous stars, perhaps because they were removed of gas or warmed excessively early in cosmic past. Some might be temporary phases in galactic development. What they every possess in common is subtlety. No fireworks, no spiraling arms, merely peaceful gravitational existence. They remind us that not every galaxies radiate. Certain ones simply exist. Black holes can impact and combine in cosmic performances. When pair black holes circle one another, They release ripples in space-time designated gravitational waves. As energy escapes, the black holes spiral inward until they combine in an ultimate traumatic instant. Pair unseen giants transforming into one. These impacts don't produce light, yet they transmit out bursts of gravitational waves that we can currently identify on Earth. The initial of these transmissions was witnessed in 2015, verifying a century-ancient prediction by Einstein. Since that time, we've identified dozens additional. Everyone relates a narrative about enormous objects impacting in distant galaxies long previously. These black hole combinations occur peacefully, invisibly, yet with remarkable force, converting complete solar masses of energy into waves that ripple across the cosmos. And for an instant, the fabric of space itself focalizes. Certain stars die in gradual motion, requiring billions of years to diminish. Not every star concludes in an abrupt detonation. Smaller stars like our Sun die considerably more gradually. Following consuming through their hydrogen fuel, they enlarge into red giants, expelling their exterior layers into space. What remains is a compact heated coal, a white dwarf. This remnant no longer generates energy. It simply radiates away its remaining heat extremely gradually. A white dwarf can require billions of years to chill, progressively dimming until it transforms unseen, a black dwarf. However, the cosmos isn't ancient enough for that to have occurred nevertheless. Every white dwarf that's ever developed is nevertheless radiating somewhere, peacefully diminishing in the dark. The death of these stars is less like a firework and more like an ember cooling gently across cosmic time. Time near a black hole decelerates compared to Earth. In Einstein's hypothesis of general relativity, gravity doesn't merely extract on matter, it curves space and time. The more intense the gravitational field, the more gradual time progresses relative to areas of less intense gravity. Near a black hole where gravity is extreme, this effect transforms dramatic. If you were to circle merely outside the event horizon, time for you would transit considerably more gradually than for someone distant away. Minutes near the black hole might indicate years elsewhere. This isn't science fiction. It's a genuine measured effect designated gravitational time dilation. We've even witnessed it in milder variety with GPS satellites around black holes. It transforms profound in a method. They don't merely capture light. They extend time itself. The void between galaxies is more frigid than any laboratory on Earth. Distant from stars, planets, or even gas clouds, the enormous spaces between galaxies are astonishingly frigid. The temperature there descends to merely several degrees past absolute zero, approximately 2.7 Kelvin. That's more frigid than any natural location on Earth, and more frigid than most environments we can generate, even in advanced laboratories. This chill originates from the near-complete absence of particles and energy. There's emptiness to maintain warmth, merely a scattering of wandering atoms and the weak microwave radiance of the early cosmos. These intergalactic voids are the most peaceful, most isolated locations we recognize. Enormous and vacant, extended across millions of light years. They are the universe's most profound shadows, maintaining only the foundation murmur of generation. The cosmos is achieving more clear as it matures. In the early cosmos, light couldn't journey freely. The universe was occupied with a heated plasma, a haze of free electrons and atomic nuclei that scattered photons constantly. However, as the cosmos enlarged and chilled, it arrived at a threshold where electrons combined with nuclei to develop neutral atoms. Abruptly, light might travel unhindered. This occurrence, designated recombination, occurred approximately 380,000 years following the Big Bang, and it released the cosmic microwave background we continue to identify presently. Since that time, the cosmos has continued to develop more clear. The creation of galaxies and stars contributed fresh pockets of light, and as matter distributes out, there's less and less to obstruct a photon's trajectory. With time, the darkness has transformed clearer. Space, previously radiating and opaque, currently allows light transit through almost unimpeded. We've captured the silhouette of a black hole. In 2019, the Event Horizon Telescope released the initial immediate image of a black hole, or more accurately, of its silhouette. The black hole itself can't be observed, yet the radiating ring of heated gas swirling around it exposes its existence. This particular black hole exists in the center of the galaxy M87, approximately 53 million light-years distance. The image displays a circular silhouette, the area for which no light escapes, encircled by a halo of radiation, twisted by gravity. It required years of global cooperation, coordinating telescopes around the planet to function as a single planet-sized lens. The outcome was beyond a picture. It was a peaceful triumph of science, providing us our initial glimpse at one of the most enigmatic objects in the cosmos. Not through fiction or hypothesis, yet through light. You can observe a galaxy with your unassisted vision from your backyard. Most galaxies are so distant away that even powerful telescopes expose only weak smudges. However, there's one you can observe without any equipment whatsoever: the Andromeda Galaxy. You are not separate from the universe. You are an instant of it produced conscious, a flicker of awareness in a cosmos that otherwise only travels and consumes and chills. In this manner, the cosmos has developed vision, and through those vision, it examines backward at itself, speculates at itself, dreams of itself. On clear, dark nights in the northern hemisphere, it manifests as a gentle, hazy oval in the atmosphere, merely observable to the vision. It's beyond 2.5 million light-years distance, indicating the light you observe initiated its voyage long prior to humans developed. Andromeda possesses 1 trillion stars, beyond double the Milky Way, and it's gradually traveling toward us. It's challenging to comprehend, yet you can examine up and observe a complete galaxy with no telescope. No filter, merely the atmosphere, your vision, and the gentle radiance of something enormous and primordial drifting in the dark. One minuscule satellite identified the murmur of a distant black hole impact. In 2015, a compact satellite designated LEGO identified something extraordinary: a weak ripple in spacetime from beyond 1 billion light-years distance. It was produced by pair black holes impacting, transmitting gravitational waves across the universe. These waves are remarkably subtle. When they arrive at Earth, they extend and compress space by less than the width of a proton. Nevertheless, with delicate instruments, we can identify them. LIGO and its sister observatories function like cosmic perception, listening to the universe's most profound rumblings. It was verification of a prediction Einstein produced a century earlier, that even in the quietness of space, enormous occurrences can transmit out waves. We can sense a single chirp from the combination of unseen giants captured by a minuscule detector on a peaceful corner of a compact blue planet. Certain areas of the cosmos are enlarging away from us eternally. The cosmos is enlarging. And that enlargement is hastening as space extends faster and faster. Certain galaxies are being propelled away so swiftly that their light will never arrive at us. Even if we waited eternally, the space between us and those galaxies would develop excessively rapidly for the light to diminish the distance. They've presently transited a threshold of no return, slipping past the cosmic event horizon. Ultimately, additional of the cosmos will diminish from perception, not because it's vanished, yet because its light can no longer arrive at us. This isn't something we'll sense day to day, yet across billions of years, it indicates the observable cosmos will contract. The universe isn't merely developing, it's also peacefully releasing. Certain black holes might be primordial, created prior to stars. Most black holes develop from the compression of enormous stars. However, there's another possibility. Black holes that developed in the initial instance of the cosmos prior to stars even existed. These are designated primordial black holes. They might have developed from minuscule variations in the compact heated conditions, merely following the Big Bang areas where gravity extracted matter together into ultra-compact knots. Certain of these black holes might be remarkably compact. Some might have developed across time. We've never immediately identified one, yet if they exist, they might assist clarify dark matter, seed the creation of galaxies, or reveal fresh insights into the early cosmos. They'd be more ancient than stars, more ancient than galaxies, quiet remnants of the initial seconds following time initiated. Entangled particles might connect distant corners of the universe. Quantum entanglement is one of the most peculiar phenomena in physics. When pair particles are entangled, their properties remain connected regardless how distant apart they exist. Modify one and the companion modifies instantly, even across enormous distances. It doesn't communicate information faster than light, yet it does indicate that reality at the quantum level is profoundly interconnected. Certain physicists believe entanglement might perform a function in the fabric of space-time itself, perhaps even assisting to maintain space together. In hypothesis, particles generated in the early cosmos might continue to be entangled presently, extended across the enlarging universe. If accurate, there might be peaceful, unseen threads linking distant areas, quantum echoes from the dawn of time, nevertheless existing in the vacancy between galaxies. The vacuum of space possesses quantum pressure. Even in perfect vacuum, where there exist no atoms, no particles, no radiation, there's nevertheless energy. Quantum physics relates us that vacant space isn't genuinely vacant. Rather, it's occupied with minuscule, restless variations. Particles and antiparticles manifesting and vanishing, fields shifting marginally, constantly traveling. This motion generates pressure, designated as vacuum energy. On large magnitudes, this pressure might assist clarify dark energy, the force propelling the universe's hastening enlargement. Dissimilar other varieties of energy, vacuum energy doesn't dilute as space develops. It remains constant, extending space faster the additional there exists of it. It's a peculiar notion that the additional emptiness you possess, the additional something it transforms. The peaceful force of vacant space might be what propels the universe apart. Black holes radiate weak warmth across trillions of years. Black holes are famously obscure, so compact that nothing, not even light, can escape their gravity. However, thanks to physicist Stephen Hawking, we understand they aren't thoroughly quiet. Based on quantum hypothesis, black holes can release a weak radiance designated Hawking radiation. It occurs at the boundary of the event horizon, where virtual particle pairs occasionally result in one particle escaping while the companion descends in. The escaping particle transforms genuine, a minuscule portion of energy extracted from the black hole. Across remarkably lengthy time magnitudes, this gradual leakage can produce the black hole to contract and ultimately evaporate thoroughly. For a black hole the mass of the Sun, that process would require beyond a trillion years. It's the most peaceful variety of conclusion, not in detonation, yet a lengthy gradual diminish into emptiness. The cosmos possesses more plasma than solid matter. When we consider matter, we typically envision solids, liquids, and gases. However, the most typical state of matter in the cosmos is something else completely: plasma. Plasma is an ionized gas, a cloud of particles where electrons and nuclei travel freely. It's discovered in stars, in the solar wind, in interstellar space, and even in the enormous areas between galaxies. Most of the observable matter in the cosmos exists in this state. Plasma conducts differently from other varieties of matter. It reacts to magnetic fields, progresses like fluid, and can transport electrical currents across enormous distances. On Earth, we infrequently observe it outside of lightning, fire, or neon illumination. However, in space, plasma is throughout, radiating, progressing and influencing much of what we observe, even when we don't recognize it. Gravitational waves journey at the velocity of light. Gravity doesn't merely extract, it can ripple. When enormous objects like black holes or neutron stars impact, they transmit waves through the fabric of space-time itself. These gravitational waves extend and compress space as they transit, traveling outward in every direction. And they journey at the velocity of light, the fastest possible velocity in the cosmos. It required decades to create instruments sensitive enough to identify them. However, currently we can listen to these cosmic ripples from Earth. Every wave bears information about distant catastrophes, how much mass was engaged, how fast the object rotated, even how distorted space transformed. Gravitational waves are quiet to our perception, yet they are genuine, quantifiable, and unexpectedly gentle. Minuscule tremors in the profound structure of the universe. The cosmic web links galaxies across the cosmos. If you might chart the locations of galaxies on the most extensive possible magnitude, you'd discover something attractive. An enormous interconnected configuration of filaments and voids designated the cosmic web. Galaxies don't exist alone in space. They accumulate along unseen threads of dark matter and gas, extending like tendrils between clusters. Where filaments intersect, we discover superclusters, enormous knots of galaxies. Between them exist immense, peaceful voids virtually vacant. The cosmic web isn't something we can observe with a telescope all simultaneously, yet its structure appears from extensive surveys of the atmosphere. It resembles a network or a foam, or even the branching configurations of neurons. It's the configuration of the cosmos on its most grand magnitudes, not random yet woven, like something developed rather than constructed. The cosmos is enormous, and you are a method for it to recognize itself. Of the peculiar discoveries in astronomy, perhaps the most peacefully astonishing is this. You are composed of stardust. The carbon in your body, the calcium in your bones, the iron in your blood, every were forged in stars, scattered across space, and accumulated into life. And even currently, as you drift towards rest, it maintains dreaming. Gratitude for spending this time present, drifting through the universe with me. We've drifted across enormous distances, past dying stars and newborn galaxies, listening to ripples in space-time and echoes from the initial instance of generation. And somewhere in every of it, in the light of primordial stars, in the quietness between galaxies, in the peaceful shimmer of dust, there existed you breathing gradually, contemplation softening, perhaps even presently already asleep. This cosmos is abundant with movement and enigma, yet also motionlessness. It maintains warmth and light and gravity, yet it also maintains tranquility. And the reality that we can recognize it portion by portion, in peace and in peaceful, is something genuinely attractive. Therefore, wherever you exist currently, whether you're thoroughly awake or drifting past the boundary of contemplation, might your dreams this evening be gentle. Might your body rest like starlight on water. And might you possess with you, even weakly, the recollection of a cosmos that radiates, not merely past you, yet within you. If you occur to nevertheless be awake, you can proceed ahead and observe the subsequent chapter currently. And if you'd prefer to drift off to additional narratives like this, gently related, occupied with marvel, reflect subscribing. There's constantly additional to examine, one sleepy soul at a time. Good night.